Hi everyone, it's Mr. Baker here with another physics video. Today we're going to be looking at a new topic, all about atomic structure, and today we're going to be looking at atoms and radioactivity. So today we're going to be looking at atoms and radioactivity, and we're going to be answering this question: where does radioactivity come from? So first of all then, let's have a little look at the background. How was nuclear radiation discovered? Well, it was discovered by this man here, Henri Becquerel, who was a French physicist. And it was almost done by accident. In 1896, he placed a rock of potassium uranol on some photographic paper in a drawer. There was no light in the drawer, and yet the paper had been affected by the rock. Now, X-rays had just been discovered, and so at first, Henri Becquerel thought that maybe it was just some X-rays being given off by the rock, but he did some further experiments and found that they could be deflected by electric and magnetic fields. X-rays can't. And so he knew that he had discovered something new. Here's a photograph of the actual photographic paper. So another name that you have probably heard of is Marie Curie, who was a Polish physicist. So after Becquerel's experiments, it was later found that it was the uranium in the rock that had emitted some kind of radiation to affect the paper. Now, Marie Curie was fascinated by the idea that the atom might not be as unchanging as we thought before, so spent her life researching radioactive materials. She discovered and named the elements polonium and radium. And she won 2 Nobel Prizes. The story continues when we look at a man called Ernest Rutherford, who is a New Zealand physicist. In 1899, Ernest Rutherford did many experiments studying the properties of radioactive decay and named these alpha, beta and gamma particles. He classified them by their ability to penetrate matter. Ernest Rutherford is most well known for his gold leaf scattering experiment of 1911 and the discovery of the atomic nucleus, and we will look at that in another lesson. And the work for this discovery was carried out by research assistants Hans Geiger and Ernest Marsden. And this is the model of the atom that Rutherford and his team came up with a nucleus in the middle, which was positive and very dense, with most of the mass in there, and then with these negative electrons whizzing around the outside. So we now know that there are 3 types of nuclear radiation: alpha, beta and gamma. So we've got the symbols there for alpha, beta and gamma, and they occur when an unstable atomic nucleus breaks down. Now an alpha particle, as you can see there, has got 2 protons and 2 neutrons, so it's actually the nucleus of a helium atom. A beta particle is the same thing as an electron, and a gamma ray is part of the electromagnetic spectrum. It's a ray of light, just really high energy. So alpha is the same as a helium nucleus. It's made of 2 protons and 2 neutrons, and so because of that it's got a charge of 2+, and is relatively heavy and slow. Beta, as we've said, is the same as an electron. It's got the charge of -1 and is quite light and fast. So these are relative charges. So a charge on an electron is actually 1.6 times 10 to the power of -19 coulombs. So we just say relative to each other, they've got +1 or +2 or -1. So an alpha particle has got a +2 charge or a 2+ charge, and a beta particle has got a -1 charge. And gamma actually isn't a particle at all. As we've said, it's part of the electromagnetic spectrum, and it travels at the speed of light. So this is what you should be able to do by the end of this lesson. Then you should be able to describe a brief history of the discovery of radioactivity, be able to describe the Rutherford model of the atom. You can state that there are 3 types of radioactivity, and then you can describe what makes up these 3 types of radioactivity. Okay, so where does radioactivity come from? This is a question that we were answering at the beginning of the lesson. So nuclear radiation can be found all around us. There is a natural safe level of radiation called background radiation, and it comes from cosmic rays from space, from rocks in the ground, and there are other sources as well. There is radiation in plants and even in the air around us. Ultimately, it occurs because the nucleus of an atom either breaks down or loses energy and emits the radiation. Alpha and beta radiation come from unstable nuclei, where there are more neutrons to protons, and gamma radiation comes from a nuclei that's got too much energy sort of left over. Okay, so that's the end of this one, all about atoms and radioactivity. I've been Mr. Baker, and I'll see you next time. Thanks very much.